Hello, Professor Bui. I have my exam 2 redemption here, and let's see if it passes all of the test cases. As that's running, we can talk about the overall architecture. So, I had decided to use semaphores, which I can talk about later, and then I have this struct up here. But you enter in main, and I parse the command line arguments, and I get like the destination and the concurrency variable that we want to set, and then all the URLs. So I can just kind of look through argc and check if one of the argv things is the flags, like the -d or the -n over here, and update those two variables accordingly. And then the leftover args will all just get thrown into URLs, so we have those. And then I can get like a destination based on whether this was set or not, or like our current working directory. So I do that right here. And then I make that directory, so I make sure it exists. And then I use semaphores so I can limit the concurrency to the the value here that we set, without having to use that like producer consumer like queue, because that like adds a bunch of overhead with the thread pool. It's like much more complicated to do that, I noticed, with locks and condition variables. So being able to set this semaphore here at concurrency makes that a much more trivial problem. So then I can make my thread array, and I decided to do a struct here with my args instead of like a global variable, because I didn't want to use a global variable, and this kind of made sense to me. So I can like set the destination. I guess this is a little bit redundant, is the only downside, but if we wanted to change it so different URLs went to different destinations, this would be much easier to expand on. And then I set the URL here, run this thread, wait for the threads to finish, collect everything, and then return the status, and you can see that it works here. I guess going into this function, so each thread enters into this curl thread function, and it has to acquire a running slot from the semaphore. We get the args from my struct here, we get the base name for the output path, make the output path, do our print, and then this is all the curl stuff. So we initialize the curl object, we check if it exists, we make a file pointer, and then we try and write to that file pointer with the curl object. Then we have 3 checks, so we have to check if the curl was successful, otherwise we indicate that there was a failure. We have to check if the file pointer, like the fopen, was successful, and if not, we need a failure. And we have to check if the like initial curl object was made correctly, otherwise failure. And if there's no failures, then it works, and we can say it finished, and we can return. And I think that's all. So that's how the program works. Yeah, we talked about our semaphores. Which concurrency patterns? We did the rate limiting one. This is like kind of like the slack line, because we only wanted concurrency amounts of threads at a time, so we bounded it by the concurrency amount here by setting this semaphore to that. And we could have also done this with like a thread pool producer consumer kind of a thing. And is this program task or data parallel? I didn't think about this before starting this video. Well, let me see here. It's doing the same thing on different URL, so same thing on different data. Let me go with task parallel, because it's the same thing but different data. I'm pretty sure that's right. And does having concurrent HTTP client improve your download speed? Obviously, because you can download files at the same time. So if you had 5 files to download, instead of it taking the length of all 5 of the files to download, it just takes the length of the largest file to download, because you're doing them all at the same time, and you only have to wait on the largest one. And I only used AI tools for some of this curl stuff to not have to look into documentation a lot, because I didn't have U for systems, so I hadn't used this other than the project. I think that's all. Thank you.